Sample problem. In the figure we have two capacitors C1 equals 6 microfarad and C2 equals 3 microfarad and an EMF source with 18 volts. Find the equivalent capacitance, equivalent charge, and potential difference for each capacitor when they are connected in letter A, series, and letter B, in parallel. For letter A, here we consider the series connection and we determine the equivalent capacitance using the equation 5. The equivalent capacitance as shown in equation A, which is 2 microfarad. The equivalent charge is calculated using the equation in equation 1, which we rewrite to solve for the equivalent charge, which is 36 microcoulomb. The charges for both plates are equal to the equivalent charge. The electric potential for each capacitor, and we see that it is given as 6 volts for capacitor 1 and 12 volts for capacitor 2 as shown in equation C and D. Note that when you sum the two voltage results to 18 volts, which is the electric potential across the EMF source. For letter B, here we consider the parallel connection and we determine the equivalent capacitance using the equation 13. We see that the equivalent capacitance is equal to 9 microfarad as shown in equation A. The equivalent charge is calculated using equation 1 and rewrite to solve for the charge. Since the voltage is the same for parallel connection, we factor it out. So the equivalent charge is about 162 microcoulomb as shown in equation F. The individual charges are given in equation GH, which are 108 microcoulomb and 54 microcoulomb, respectively. The electric potential for each capacitor is equal for all capacitors in parallel connection, and we see that both capacitors have 18 volts.